All right, welcome to skill video 1, just factor in Toolkit. So this video is just going to kind of quickly look at different ways we can factor as we kind of work through questions, right? So wherever you're at, hopefully this factoring video helps you. So just quick Toolkit check there. So at the start, before we're factoring, we are just kind of asking common questions. So number one, is there a greatest common factor? If there is, then we could pull it out. It's probably a good idea. Number two, how many terms do I have, right? So this will tell us about different patterns, 2 versus 3 especially. And then does this match a familiar pattern? Because the idea with factoring is going to be, can we factor, right? I'm going to talk about some specific ways, but really, can you factor a question? If so, that's good, and you're probably fine, right? So don't stress too much about the exact method. Just be able to factor. So here's the first one. So you can see factor 6x squared minus 15x. So again, my first thought should always be, is there a common factor? So this question, 6x squared minus 15x, well, yeah. So I can see 6 and 15, I can divide them by 3, and then x squared and x both have a factor of x. So if I pull out the 3x, what I'm left with here, 6x squared, is going to be 2x. Remember, that's basically division, but I'm not actually removing it. Negative 15 divided by 3 is negative 5, and I remove the x. So 3x minus 3x times 2x minus 5, and we're done. Right? There's nothing else to do there. There's nothing else in common. That's not a pattern. We're done. Next, I do a little simple trinomial. So x squared plus 7x plus 12. Now, this is a work step. I don't need to see it. I'm going to put it in green. What I am thinking here is I know that this thing is it's going to break down into two binomial factors. Each one has an x because I know my first expansion, x times x squared. Okay, easy. And I noticed that a leading coefficient of 1, which makes this question a product sum. Just a nice, easy factor. So what I'm doing in the background here is I am trying to find two numbers that multiply to 12, the c term, and then add to 7, the b term. This is just practice finding those numbers. I know it's going to be 3 and 4. 4 and 3, 3 and 4, order doesn't matter. Now, all I do to finish this question off is I'm going to put the positive 3 in one bracket, the positive 4 in the other bracket, and I'm done. That's it. Now, again, I don't need to see, like that's just extra. We don't need to see that as long as you can factor it perfect. So now here's one for you. So I want you to factor x squared minus 5x minus 14, and you're just kind of asking yourself, what product do I need? What sum do I need? And then try it. So pause the video, and we'll kind of come back for this one together. And there you go, x minus 7, x plus 2. And remember, as always, you can just use the distributive property if you need to check this thing out. If you need to check the answer, that's perfectly fine. Okay. Next question. Leading coefficient, not 1, right? So I'll often denote these as a is not 1. So see 2x squared plus 7x plus 3. So we do have options here. My key setup is going to be decomposition. I'll do this. It is going to be too much for a lot of questions, but I'll do one. So what decomposition is going to say is, well, okay, so I have 2x squared plus 7x plus 3. What I'm going to do is a really similar strategy. I'm finding two numbers that multiply, two numbers that add. Now the add-in looks the same. It's going to add to that middle term b. The two numbers are going to multiply to a times c, so 2 times 3, which is 6. So when two numbers multiply to 6, add to 7, it's going to be 6 and 1. So 6 and 1, 6 and 1. And when I find those numbers, I am going for the product first, right? So I'm kind of thinking there, I can multiply 1 times 6 or 2 times 3, and then I go for the sum, right? The product is really going to narrow down your options. So once I have that, what decomposition is going to say is, well, I'm going to leave the 2x squared and the 3 alone, but I'm going to decompose. I'm going to break this down into a 6x, 6 plus the 1x. And then I'm going to factor these as pairs. So this first pair, I'm going to say, well, it has a common 2x, which leaves x plus 3. And the second pair has nothing in common, so 1, x plus 3. And then I say, look at that x plus 3 can come out all together, which is going to leave a 2x plus 1. And that's it. We're done. Now, there are, of course, other ways to do that, right? For that one, I would honestly just do inspection. So when I say 2x squared plus 7x plus 3, I'm just going to say, well, I know I'm going to have two brackets. Because I multiplied a 2x, I know one is going to have a 2x, one's going to have an x. And then what can I do? So I know to multiply to 3, these numbers are going to be 1 and 3. So that's going to be 1 or 3, and that's going to be 1 or 3. So let's just try the 3 over here and the 1 over here. I see that that gives me the 7xb term, and I'm done. Okay. Let's try another question. Oh, undo that. Okay. So your turn. Factor 3x squared minus 10x plus 8. And again, do whatever you want, right? You can do decomposition. You can do inspection. I'll show a little crisscross method on this next one, but yeah, do this how you want. Okay. Here, this one is done out. So you can see ultimately the answer is x minus 2 times 3x minus 4. On the right there, I did a little crisscross method, a little shortcut. I won't talk too much about it, but it does work. And again, just be able to factor these, right? And remember, if you ever want to expand them, you can expand them with the distributive property. Okay, last question, little pattern. Difference of squares. So 9x squared minus 25. What I'm thinking on this one, 9x squared minus 25, is if I have a difference of squares, which is something squared minus something squared, a squared minus b squared, it's going to factor into a plus b times a minus b. So in this one, you don't have to show this step, but what I'm going to say is, well, 9x squared is just 3x all squared, and 25 is just 5 all squared. So 3x is really a, and 5 is really b. So this question then is going to be a plus b times a minus b, and we're done. That's it. So that's that kind of pattern. Two terms are subtracting to both perfect squares, difference of squares, move on. One for you, factor 4x squared minus 49. Pause video, try it. We're back, there you go, right? So these are just hopefully rote, and factor in, if you need practice, practice. That's it, it's just a skill. So just wrapping this video up, little checklist. First, always look for that greatest common factor. Count the terms. If you have two terms, you're thinking difference of squares. If you have three terms, it's probably some sort of product sum. If A is not 1, you can use decomposition, or you can use crisscross, or you can use inspection. It doesn't matter, just be able to factor. And then finally, if you want to, check the factors, multiply them together, see if you get your kind of original expression back. If you do, perfect. If not, try something else. And that's it. Thanks for watching.